Tonight we'll talk about the galaxies that are in the spring skies. We'll talk about the galaxy clusters, and we'll talk about a challenge galaxy in Hercules. Then we'll head up on the mountain and see what we can see through the telescope. Hello friends. Lately I've been thinking about galaxies and how it's a good time of the year to see galaxies. It's mid-April as I make this video, and the evening sky in spring is like a vault of fine galaxies. Some of these galaxies are even visible in small telescopes. But the bigger the better for your telescope when you're observing galaxies, I have to admit. I was recently observing galaxies with a 22-inch telescope. On a telescope of that size, most of the details which any particular galaxy is known for will jump out at you, but the difference as compared to smaller telescopes isn't so much. I mean, for example, we observed NGC 891, and the dark lane across the galaxy jumped right out at me. But you know, no telescope really makes galaxies look like they do in photographs and images. The 22-inch telescope was only moderately better on galaxies than the 10-inch telescope that I had with me. But when trying to see things right at the limit, every little bit of light, or I guess I should say every photon, counts. You know, many years ago, I had only a 2.4-inch telescope available. It had a lens this big. Yet I observed many galaxies with it. You might not think of such a small telescope as being a galaxy instrument, but again, those objects don't look like photographs no matter how big your telescope. I think you have to remain a little bit philosophical about it. When you see that smudge of light, you have to remember you're looking at a huge number of stars, perhaps hundreds of billions. A galaxy has to be very far away for it to look like it does. Well, anyhow, the reason spring is galaxy season for us here in the northern hemisphere is because in the evening sky, we're looking out away from the center of the Milky Way galaxy. Now later in the summer, the Milky Way will be prominent up in the evening, but in spring, we're actually looking out away from the center of the Milky Way and up towards the North Galactic Pole, which is in Coma Berenices. Without so much in our own galaxy to block the view, we can therefore see many external galaxies. Well, even if you aren't good at locating objects, it's still easy to see galaxies just by pointing your telescope a little south of the fuzzy Coma star cluster, which you can see with just your eyes if the sky is dark. And if your telescope is 8 inches in diameter or bigger, you might have a hard time keeping count of all the galaxies you'll find around there. I would note too there are a couple globular clusters in the area, so if the galaxy that you've discovered looks pretty round, you might go in with power and see if it shows any individual stars. And if so, it's a globular cluster in a part of our Milky Way galaxy, a halo object around the center of our own Milky Way galaxy. None of the galaxies will show individual stars at any power in our telescopes. Now, the three main galaxy clusters we're dealing with in these spring nights are the Leo cluster, and the Virgo cluster, and the Coma cluster. Now, let me say that again, I'm getting confused. The Coma galaxy cluster gets a little confused because Coma Berenices also has that famous Coma star cluster, which I just mentioned. And the Coma star cluster, under dark skies with just your eyes, looks like a little patch of fuzzy light. And in legend, it was Berenice's hair, but it also looks like a little fuzzy patch that could be thought of as being at the end of the Leo the lion's tail. That's how I like to look at it anyway. But like I said, this little fuzzy patch, the Coma star cluster, makes it very easy to find galaxies because you only need to move a little south of the star cluster to find the galaxy cluster. Now don't worry, I'll show you all this when we take the telescope out tonight. But in fact, as you move south out of the Coma star cluster, the fuzzy object you're likely to see first is Galaxy M85, but it'll look just like a little fuzzy oval. Well, again, we have to keep in mind what we're seeing. The relative dimness of these objects is actually incredibly impressive when we realize how far away they must be to look that way. Well, anyhow, the Virgo cluster is kind of hard to differentiate from the Coma cluster when we're just out there looking at the sky, but it is a separate cluster. The Virgo cluster is the core of the Virgo supercluster, and our local group of galaxies is a part of the Virgo supercluster. Both the Milky Way and the great galaxy in Andromeda are heading that way towards the Virgo cluster, so we're heading towards the Virgo cluster. Now, speaking of the great galaxy in Andromeda, you know, spring is galaxy season, but the greatest galaxy of them all as seen from Earth, the Andromeda Galaxy, is out of season and more or less in conjunction with the Sun. So we won't be able to see it on those spring nights. Anyhow, though, While the Coma Virgo clusters show the most galaxies, the Leo cluster isn't too far behind. Some sources even refer to the Leo cluster as multiple clusters, but it doesn't matter to us. What we care about is the fact that M65 and N66 in Leo are very easy to find, and they're right there below the lion's outstretched legs. I observed them all those years ago with my little 2.4-inch telescope. It's decades ago. I was using a little tiny and junky eyepiece too. So if I could see them with that telescope set up, it's pretty much guaranteed that you can see them in yours. In a bigger telescope, you can see the characteristic shape of the galaxies and maybe just a hint of detail. Now next to M65 and M66, you might see a third NGC galaxy there with them. From here in town, I was able to make out M65 and 66 the other night, but the third galaxy, which makes up the Leo triplet, just wasn't making it right through the light pollution. But we'll try again tonight up on the mountain. I like to just pan around in these galaxy clusters and see what I can find. Now, if you have a good chart, you can keep track of where you are so you know which galaxies you're looking at. For example, the little book I like, the Observer's Sky Atlas, has this chart in it, which is handy for the Coma and Virgo clusters. It also has another chart for the Leo cluster. Now, while I'm out there, I'll be sure to head up north and I'll check out M51, the Whirlpool galaxy in Canis Venatici. This galaxy is so easy to find because it makes a right angle with the last two stars in the Big Dipper's handle. Though, as I say, the galaxy is actually in Canis Venatici, which are the herdsman Buttes sheepdogs. Buttes is right nearby. Well, anyhow, I'd say it's a toss-up for me which is better to see. M51, the Whirlpool galaxy, or M31, the Great Galaxy in Andromeda. M31 in Andromeda is closer and it looks bigger, but M51, the Whirlpool galaxy in Canis Venatici, shows some really great spiral detail. Check out this live footage I captured last month. That video was actually taken from here in town. It'll look even better up on the mountain. Now, the detail you'll see visually in galaxies does depend a lot upon your sky brightness and your light pollution. In fact, when I was getting that video of M51, all I could actually see of M51 in the telescope here at home under my light polluted skies was just a very faint blur that I could hardly make out at all, with no detail. But if you're under a dark country sky, you can see those spiral arms in an M51 pretty easily, I think. And there's also a bridge of matter there connecting the galaxy to its little companion, and that little companion evidently has already gone crashing through M51. Well, there are other good galaxies around the Big Dipper like M81, but from what I understand, the galaxies in this part of the sky don't seem to make up one unified cluster. In fact, M51 is considered to be the flagship galaxy of its own group, and so is M81. Well, the large-scale structure of galaxy clusters, though, it's incredible, because at very large scales, galaxies are in structures which mimic the structures seen in nature at much smaller scales. There are filaments and bubbles in the structure of galaxies. Not every reference agrees to which galaxies belong to which particular structures and which clusters, though. I guess that's just how it goes with science. But anyhow, the nice thing about the galaxies we're talking about is how easy they are to find. You know, these are perfect targets for the Telrad type finders. I can usually find them by putting the bullseye in the Telrad on the spot and then wiggling the telescope around a little. You can use the Rigel finder like the one I have on this Pentax behind me in just the same way. Well, as the spring night wears on, the large constellation Hercules will be in the sky. Now, everybody knows the great object in Hercules, that's M13. It's the globular cluster located on one side of the famous Keystone asterism in the constellation of Hercules. But I think there's a challenge right there right next to M13, a galactic challenge next to M13. The galaxy NGC 6207 is right next to the globular, but I'm sure many have never seen it. I didn't know it was there until I did some observing from a mountaintop with truly dark and natural skies. Now, at that point, it was quite evident. It's right next to the cluster. If it's there, you can't, if you can see it in your skies, you can't miss it. So anyhow, when you have your look at M13 this spring, you ought to give the little galaxy a shot. It's listed at magnitude 12, but under a dark sky, you shouldn't have any trouble seeing it in an 8-inch, maybe even a 6-inch telescope. And it's said that this is a good example of cosmic scale, too, because they say the galaxy is around 1,250 times more distant than the globular cluster. Well, my attempts to image the galaxy in town here didn't work out here. As you can see in the live video, you can see M13, but I just couldn't get the galaxy. But I'll try again when we're up on the mountain tonight. Well, anyhow, while galaxies might not present the most fantastic views in the heavens, they are still incredible objects to observe. Imagine how far away something with billions of stars in it must be to appear as just a smudge of light, even in a large telescope. In their own way, this makes galaxies the most impressive objects in the skies. Also, you can observe galaxies with any instrument, any telescope, or even binoculars. And if you don't know where to find them, don't worry. Just check out my other videos where I talk about a couple of little books that are inexpensive, but which make it easy. They show you right where they are, no problem. Well, anyhow, let's head up to the mountain and see which galaxies we can find tonight. Okay, so we're looking now at Leo. Leo is like a lion stretched out as a sphinx, and it's like he's seen from his right side. He's stretched out, and there's Regulus, the famous star, and here's his front paw, his front leg, and up here is his head. That's the head of the lion. Remember, he's stretched out like a sphinx. There's the head of the lion, and now the body of the lion, right there, see? Coming around to Regulus right there again, the body of the lion. And now his rear leg stretched out behind him. He's stretched out like a sphinx in the sky. The nice thing is, we can come right down to this area right here, and M65 and 66 are right there, so it's very easy to find these two galaxies. Very easy to find them. So now we're going to look at M65. Now, this is a galaxy about 35 million light years away, and this is about how it looks in the telescope. This is a live view, this is a video view, and you can see there, if you look closely, you can just start to make out some of the detail of it being a disk-type spiral galaxy. Now look at this picture I took a few minutes ago. You can see a little more detail in it. You can see a little bit of clumpiness in there, which are some of the star-forming regions probably. This is how it would look in a very, very large telescope. It's never going to look like a picture though, like an image like you'd see in a book or magazine. Here's another view again, looking at M65. This is a live view with the gain turned up a little bit. And this is how it'll look in a telescope, sort of a medium-sized telescope. Galaxies never look like they look in books or magazines when you look through a telescope, but you got to remember that's billions or hundreds of billions of stars, so it's really pretty impressive just the same. Now we're looking at M66. Look closely and you can just start to make out the spiral arms. Now this is a live view, this is a video view, this is how it really looks through the telescope. This is how it looks through a medium telescope. There's sort of an S shape to this galaxy. There are two very prominent spiral arms that make an S shape, and that's kind of what it's known for. It's not that easy to make it out just looking through the telescope like this. Now take a look at this picture here that I took a few minutes ago. You can start to see a little more of that S shape, sort of that swirl to it, and you can see those clumpy areas, those H2 regions, which are probably star-forming regions. And here we are with the gain turned up again on this object. And we're changing it around a little bit, but it's not helping too much. This is how galaxies are, though, when you look at them through the telescope. This is a live view. This is how they look, and you got to remember that's billions or hundreds of billions of stars, so it's got to be pretty far away to look like that. So now let's have a look here at Coma Berenices. Now these three stars here, remember, those are the rear legs of Leo the lion. And over here we have Berenices' hair, right here, in the Coma star cluster. And it could also be said to be the poof at the end of the lion's tail. But anyhow, we just come down from the Coma star cluster into this area, and we're sure to find galaxies. If we just go panning around there, we will find galaxies. There are so many there, like M85. We're looking at this lenticular galaxy here. We have the lenticular galaxy, and you can see a little faint galaxy that's in the IC catalog there as well. And these galaxies like this, you know, there's nothing to see in terms of detail, and this is a live view. This is how it looks through the telescope. Nothing to see in terms of detail, but it is pretty incredible to think of all those billions of stars just making up a little fuzzball out there because they're so far away. Okay, so now we have the Big Dipper. You see up here it's bowl, and down here it's handle. Again, up here the bowl, and down here the handle. And if we come off at a right angle from the end of the handle right here, that's where we can find M51, the Great Whirlpool Galaxy. And this is one of the greatest galaxies in the sky. Let's have a look here at it, and this is going to be a live view. And this is how it really looks through a telescope, through sort of a medium to large telescope. And you can see there's so much spiral detail visible. You can start to see some little modeling in the, spiral arms, and that's from various, clouds of gas and dust and H2 regions where stars are forming. Also, if you look over there to the right of it, you can see that companion galaxy, which is a little galaxy that's already crashed through M51. And look closely, and you can see that it's drawing a bridge of matter off of M51. So it's really impressive. M51's a really neat galaxy to look at. It's not as big and massive as the Milky Way. It's less than half as massive as the Milky Way. But it is an incredible galaxy to view. I don't think there's any other galaxy that will show this much spiral detail. And M51, by the way, is said to be 23 million light years away, so at the rate that goes with galaxies, we're probably very lucky to see this much detail in any galaxy. Like I say, this is a live view of the galaxy through the telescope. So now we're going to have a look at Hercules. And Hercules is an exciting constellation. It's big, but it's portrayed upside down as seen from the northern hemisphere. So just for the heck of our discussion here, I'm going to turn it around, and here we go. And now he's right side up, and we have a tree down here, but don't worry about that. Hercules is a big constellation, but most of the stars are only third or fourth magnitude, so it's really a little bit hard to see sometimes from in town. But if you look around at this area right here, bottom of center, take a look right here. See how this shape is? It's shaped like a keystone. And this is the most famous shape in Hercules, and we'll come back to this in a moment. But this shape is very famous and important. The keystone shape is the easier part to see of Hercules, and much of the rest of this is tough. Look at it, there's his knee and his foot. That's like his left leg. His knee and his foot, it's bent. It's like he's taken a knee like these football players are doing. That's his knee right there that's on the ground. Just right there is his knee that's down on the ground. He's kneeling, like I say. If you look up here, this is his upper body, his chest and his upper body. It's not that easy to see. Now this area over here is his right arm. He has his right arm up in the air and he's holding his club. In ancient times, the club of Hercules was a famous symbol, and people carried little 2-inch versions of them made out of like silver around with them. And this is his left arm, and he comes over there and he's kind of holding like a bouquet of flowers and snakes and so forth. So his left arm's over here. And now, if we look up here in this area, you see the bright star up at the top. That's Raj Algeti, which is the head of the kneeler. So that star is his head, and there's not a lot of detail there to really make out the head besides Raj Algeti. That's it. Raj Algeti is a wonderful double star. There it is, but I couldn't get a good video of it because the components are very close together, and the sky was really boiling when I tried. But anyhow, let's come back to the keystone here. The thing about the keystone is that M13, the famous globular cluster, is down here. In fact, it's located right there. So you see the keystone makes it very easy to find M13. And if we come from M13, like I say, we can come off of M13 and see if we can find that galaxy I mentioned. So let's have a look at this and see what we can find. Okay, so there's M13, the Great Globular Cluster, probably around 24,000 light years away, but well within our Milky Way galaxy. These globulars make up the halo objects around the center of our galaxy. So anyhow, I changed the game now, so we can go looking for that galaxy that's near M13. We're going to move off to the northeast a little bit and see if we can make that out. It's NGC 6207, and it's about a 12th or 13th magnitude galaxy. We should be able to find it over in here. I think I see it already there. Oh, there it is. There it is at lower left. Okay, let's bring it up into the center here. And this is just a live view. This is about how it looks through the telescope. So we'll move it up to center and have a look. And there it is, just right at center. And NGC 6207 is 30 million light years away. So they said that this is kind of a demonstration, of scale. The globular was 24,000 light years away, give or take. This galaxy is around 1,200 times as far. 30 million light years away. And it doesn't look like too much as usual, but remember, the galaxies are billions of stars, and that's an incredible thing. And they have to be really, really distant to look the way they do. Well, anyhow, if you get your telescope out this spring and start looking for the spring galaxies, just remember that although they may not look all that impressive in the telescope, often appearing as just a little blur, the fact is that the galaxies are incredibly impressive. For billions or hundreds of billions of stars to look that way, they have to be very, very distant. And it just gives us a feeling for the scale of the universe and just how big things really are. I think that observing galaxies is really exciting, even though they don't give a lot of visual return. But you get a lot out of it just the same when you look at that and you realize just how big the universe is. So thanks for watching, and good luck with your own quest for the spring galaxies.